Hello, this is John from caveofprogramming.com, and this is a tutorial on interrupting threads in Java. So if you've done any multi-threading work in Java, you will have come across interrupted exception over and over again. And to be honest with you, this is kind of a flaw in Java multi-threading, arguably, because you're always forced to handle that exception, and it just makes the code look messy. But you can make use of it if you want to, and I'm going to show you how to in this tutorial. So I've got my main program in Eclipse set up here, and I'm going to put just a sys out saying starting there, and before the program finishes I'll have a sys out saying finished, and in the middle here let's have some code that just runs some stuff in its own thread. So I'll say thread equals new thread, and I'll say thread.start, and I'll have thread.join because I want my program to wait for this thread to terminate. And here I've got to handle one of those interrupted exceptions that I was just talking about, so I'll put in a throw here to throw it out my main program. And in here I'll put some kind of labor intensive code to simulate doing some kind of work that uses up a lot of CPU. So let's add the run method here, and I'll have a random number generator like that, and I'm going to have a loop, a big loop here. I'll start it at 0, and I'll keep it going for 1,000,000 iterations. So I'll use scientific notation here and say I less than 1e6. So that's 1,000,000. It's 1 times 10 to the power of 6, or in other words, a 1 followed by 6 zeros. And in this loop, just to use up some processor, I'll say math.sign, and I'll make sign work on the next double random value got from a random number generator. So this is just some labor-intensive code, and let's run that and check it works. So it starts and finishes very quickly, and if I increase this to 7, so obviously how long this takes will depend on how powerful your computer is, and there's a noticeable pause now. And if I go up to 100,000,000 iterations of this, now there's a few seconds in between the start and the finish. So after I've started the thread, I'll sleep for just half a second to give it time to really get underway, and then I'll say, actually maybe rather than call this thread, to make it a bit less confusing, I'll call it T, which may be slightly simpler. So normally you don't give like a variable just one letter name, but here I think it's pretty clear what T is. So, and I'll say t.interrupt. So what t.interrupt does is it attempts to interrupt the thread. So what would you think will happen if I now run this code? Because we're starting the thread, which takes a few seconds to run, but after half a second I'm calling t.interrupt. Let's see what happens. It does, in fact, exactly the same thing as before. Because t.interrupt does not kill the thread, and there is actually a thread.stop method, but as you can see from this line through it here, it's actually deprecated, and we shouldn't use that. It's deprecated because of reasons having to do with if you just kill a thread, it's not very pretty, and you could have problems with your state not being left in a good state or something like that. So really, if you want to stop a thread, probably the best method to do it is the method that I showed you in the second tutorial. Just use a volatile Boolean flag or something like that. But you can nevertheless, this of course does have a function, and we'll see what it is. Supposing I have either a wait in here, or it could be a sleep, or basically probably anything that throws an interrupted exception. Thread.sleep throws an interrupted exception. So let's have a sleep for 1 millisecond in this loop and just handle the interrupted exception. And if the interrupted exception is caught, I'm going to say we've been interrupted, and I will then just break out of the for loop to terminate it. So if I run this, you can see that thread.sleep does get interrupted, and it throws this exception, and then I'm deciding what to do about it, basically. And how does thread.sleep know that the thread has been interrupted? Well, what interrupt does is it just sets a flag in your thread, and you could check that flag yourself if you want to. And the way to do it is, so I'm going to say if this flag is set, I want to do sysout, and I'll say interrupted, and then I'll just break as before. And what I need to check is I need a kind of handle to the running thread, and you can get that by saying thread dot current thread. It's a static method of the thread class. Dot is interrupted. So I say if thread dot current thread is interrupted, then I will gracefully terminate my thread. And if I run that, you can see that it works. So just calling interrupt on your thread object causes this flag to be set, which you can then detect using this line of code here. Let's see how that would work with a thread pool rather than a thread object. So I'll copy this code here. I'll cut it in fact with Control X, and I'll do a very similar thing here, but I'll use a thread pool. I'll say executor service exec equals executors dot new cached thread pool, and this is all stuff that I covered in previous tutorials in this series. And I'll submit a callable to that. So I'll say new callable, and let's parameterize it just on void. I don't need the return type. And I'll implement the missing method here, which is this call method, and I'll get a future from this as well, so I can control the thread. I'll say future, and if you use void for the type for callable, you should use question mark in the future here. And I'll call that just foo equals, and add the input there with Control Shift O. And now in here, I'm just going to paste the code that I used before, like this. So we've got this code that does some labor intensive stuff, but it does check to see if the thread's been interrupted. And now there's two ways we can interrupt this code now. So once again, well, after I've submitted my code, I'm going to just do exec.shutdown, which, as I said in a previous tutorial, it won't kill your program. It will just shut down a kind of managerial thread that this thing runs, which means that your program will terminate after, or rather, basically your program will terminate after the threads are finished, rather than just being kept alive, because this is still running a thread. This would still run a thread by itself if you didn't call shutdown, and you want it to just finish doing what it's doing and let you shut down. But anyway, so I'll call shutdown, and then I'll have that sleep in again just for half a second. And so if I run this now, it's just going to basically, oh yeah, and also I want to wait here. So I need the equivalent of thread.join, and I want to say exec.await termination, and let's just wait for like a day. Not that it's going to take a day, but so now this is the same program that I had before, basically. Starting, and it does all this code, and then after a while it finishes. I've also got that thread sleep in there, so it's going to be half a second slower. Quite a lot slower. I don't really know why, to be honest, but anyway, So now, after half a second, what I can do is I could use the future object to cancel the running thread, and that will have the same effect as calling thread.interrupt. It will set this is interrupted flag. So cancel takes a Boolean argument, and if you say false, then it will cancel the thread if it hasn't already run. But if it is already running, it won't. So you see, this doesn't change anything. But if I set that to true, it will set the interrupted flag after your thread started running. So if I run this now with true, you can see that we're catching this interrupted status here. And the other way to do it, I'll comment that out, is of course you can call exec.shut down now, which, unlike shutdown, which just shuts down the managerial thread after all the threads have finished running, shutdown now attempts to kill all running threads, but again, it doesn't literally kill them, it just sets that interrupted flag. So if I run this, again, same effect. So that's basically pretty much all there is to interrupting threads, as I know. And maybe it's sometimes useful, but you could equally well just use a Boolean flag most of the time. But it could be handy if you want to use your future to tell your threads to stop running for some reason. I don't know. I've never felt the need to use this system really, but you could find a use for it, I'm sure. Okay, so this code will be on kvolprogramming.com, and there's going to be maybe just one more video in this series. The next one is going to be on multi-threading in Swing GUI programs. So join me again for that. And until then, happy coding.